So in this section, we're going to turn our attention towards the non-quantitative data, i.e. the qualitative data, the text data, the verbatim responses that customers have provided to us when we've asked them, why did you give us this score? And as you'll remember earlier on, I said that some of the customers have actually provided that. We've got just over 1,600 verbatim responses here in answer to the question, well, why did you provide the score? So we've got a field called guest reason for the score. We've got the guest number. We're reading it from an Excel file here. And we're simply looking at the data at the moment. So we can see that, they've said, various things. They've talked about lots of different aspects of their stay. It could be, whether they're talking about the service or the facilities or the price or the parking or the location. And sometimes they're quite verbose and sometimes they're much more clipped and short. And what we're interested here is whether or not we can actually utilize this information. Can we mine it in some way to pull out common themes, to find out what topics people are talking about? Can we categorize that? Can we see relationships and correlations within it that might help us understand what's driving negative or positive recommendation scores? And to do so, we use the text analytics extension that exists within SPSS Modeler. And here I'm connected my text analysis node to the NPS comments, and I'm mining the text, the field guest reason for the score. If I just right click on it and show you something, here we have, I'm using what's called a text analysis package. You can see I'm using something called hospitality2.tap. That's a file. It's actually a library. It's a library that I've created specifically for this application. And we would normally do this as part and parcel of the predictive promoter solution. We would expect to help our customers, set up their own library and create their customized libraries. If they don't do that, then they can still do text mining, and there's a lot of resources already built into the system that will deal with positive and negative comments, do sentiment analysis, pull out entities, as it calls, non-linguistic entities like telephone numbers and dates and prices, and identify issues with budgets or payment, etc., etc. There's a lot of resources in there that you can already use, but obviously it makes sense that if you can customize it towards a particular application, you should do so. And I've done it in this case. Now, to see what happens when I run this, if I just execute that, it probably makes sense for you to actually see the results before I start talking about it. What it's doing is it's reading the text, and it's going to pull out a series of what it calls concepts or terms that it's finding in the text. So it's kind of trying to separate the wheat from the chaff, if you like. And not terribly surprisingly, the most commonly occurring concept that it finds is the term room, because it is, after all, about hotel stays. Next thing is hotel. Then we have phrases like excellent, or things related to the staff, whether positive or negative. We have items related to breakfast, to comfort. If I look at clean, for example, here and hit display, I'll see some examples of people where they've mentioned cleanliness, and we get small but clean room. We get phrases like very clean, nice clean hotel, all very clean, etc., etc. You get the same thing with the term, comfortable and comfort and that sort of stuff, where people are talking about the comfort and and so forth. Now, what we can do with the concepts is we kind of group them together into what we call types. So here are the types, and the types are related to, for example, again, cleanliness or bathroom, but you have things like negative terms that people are using. So, if you look at negative terms that they're talking about miserable or poor or awful, or they'd like a bigger room, or so on and so on, or terms related to staff front of house, whether it be reception or the concierge, and so on and so on. And what we do is we use these types to help us create categories to talk about what people are actually mentioning, what topics are they mentioning. And if I use these concepts and these types, I can score the data and attach people to specific categories. So I can say, for example, here people are talking about clean, or people talking about friendliness. If I say, show me the 267 responses where people have talked about friendliness, you can see the term friendly coming up here a lot. So people are mentioning that. And here are the other categories that people are talking about, whether or not it's friendly, noise related, unclean, disappointed, doors and keys, and so on and so on. So we're kind of categorizing the data here. And one of the things we might be able to do is to find relationships between these categories. But to do so, it makes sense for us to create what's called a text mining or text analytics model. If I click on this little button up here and say generate model, so far you've seen me generating models of a predictive analysis purpose. So things like C5 or logistic regression or predictive model. Here we're not really trying to predict an outcome. Here we're trying to classify the data. And if I attach a table node to the edge of this model and run it, you'll be able to see what new data this creates. And the new data that it creates is in the form of a series of flag fields. So it's basically saying, did you fall into this category, true or false? Most of them are falses here. But for example, if I look along here, T for true for not working. We've got two rows of data there. You can see people saying things like the bathroom light doesn't work. So they're falling into that category. If they mention things like unclean or lack of cleanliness here, so you've got issues of cleanliness in the same record. So the same bathroom, and dirty cups, for example, hairs in the bed. Issues of cleanliness are being flagged here. And again, this is quite useful because it allows us to categorize, what people are talking about, and we could analyze that, just as part of a business intelligence platform, or do some reporting on and say, here are the things where people are mentioning. But we might go a little bit further and say, can we find some sort of relationship between these categories? Are there things that might be related to positive or negative experiences, for example? And to do so, I'm going to actually visualize the data. I'm going to visualize the data by going to the graphs menu here and calling up what's called a web plot. And a web plot is a way of showing the relationship between a series of categories. I'm going to give it a little bit of help here and tell it which ones I want it to look at. So I'll look at all of these new category fields that have been created. And if I just run with the default settings on that, it will create a web of interactions or a web of relationships between the categories. Some of these relationships are very, very faint because they're not very strong. So to boost it and to pull out the signal, I will just double click on this arrow at the top and go down here to the web display menu and just change what represents a strong link or a weak link by using these sliders. And you can see here everything else has been set as a weak link. If I then just mask out the weakest links, showing just the strong ones, what we see right away is kind of interesting, strong relationships between comfort, cleanliness, the term excellence, and friendliness. So if there were three things this hotel chain needed to get right to really drive up excellence or drive up positive experience, it's friendliness, it's comfort, and it's cleanliness. Interesting enough, these terms are also related to terms like weekend, which is also related to excellence. Couples are related to excellence. So it looks like they're doing a pretty good job for couples who are maybe doing romantic breaks at the weekend, etc., etc. So that's kind of interesting. We're starting to see some relationships here where you can play around with this. We could do exactly the same thing where we focus on negative aspects and say, well, let's just look at the relationship between the negative things and see what things tend to correlate there. But perhaps more interesting than that, is there a way that we could actually predict somebody's net promoter score based upon the reasons that they've given in the verbatim text? And in the next example, that's exactly what we're going to do. So now that we've used text analysis to categorize people's responses into trues or falses in terms of the topics that they mention in their comments for why they gave the score that they did, we're going to try and predict which category they belong to in their recommendation score, i.e. whether or not they are a promoter, a passive, or a detractor. And to do so, of course, what we're going to need to do is pull in additional data. So if we look at the original MPS comments data that we have, we don't actually know what score they gave. That's back in the hospitality operational data back here, and I'm actually going to read that data and I'm going to merge it with these new fields that we've created. And to do so, I simply click on the merge here, node, I connect them up together. I just tell it to merge them by this key guest number, and if I look at what that produces, it's very simple. I've masked out everything but the category and the guest number ID. So here we have the category, here we have the reason for the score, and here we have these flag fields that have been created. I've kind of just used these flag fields to try and predict what category they belong to. Well, if I go back and go to the modeling technique, you saw me use a modeling technique earlier on, such as C5. I'll use that again, and this time I'll just tell it, you know, how to build this model by putting in what's called a type node here. I'll tell it that the guest number is in fact the record ID, that we don't want to use the verbatim text, that the target that we're trying to predict is the MPS category. Sorry, I'll switch it around. MPS category. We don't want to use the verbatim text, so we switch that off. We click OK. I'll just make a couple little changes to this. I'm going to go in and say I want it to have group sizes of at least 10. If I run that, it goes off and it starts building a decision tree. It's done it very quickly. And if I look inside that tree, we'll see, well, it's chosen from the text categories to predict this outcome. What we're finding here is that the category excellent is very important, the category noise related, category unclean or disappointed or upset. These are the most important fields in the model itself. And if we look at the model itself, we can see that it's saying, well, basically, there aren't very many people who've mentioned lack of cleanliness. It's only 72, but pretty much all, 86% of them have fallen into the detractor group. So it's a pretty important factor. For those who haven't fallen into that group but have mentioned that they're disappointed or upset, then 53% of them are in the detractor group, whereas those that didn't, 50% are in the promoter group, and so on and so on. So we start to go down through this. And they've got a bit of an issue here with wedding related activities where not very many people none of them are showing themselves to be promoters. People mentioning terms like average. So most of the initial terms are really the negative things. It's saying, if they mention these negative things, then you're really not likely to be to give them a high score on that recommendation scale. But if they're mentioning things like friendliness, 77% of them fall in that group. And each time we're going to the subgroup, it's basically a series of rules. We can see the entire tree out here. It's basically separating the wheat for chaff and saying, if you don't mention these negative things and you don't mention these other negative things and you do mention these positive things like you would recommend, for example, obviously, and a large proportion of them fall into the promoter group. So this helps me figure out, well, what are the most important fields that are driving the net promoter category that they're falling into. With regard to how accurate it is, well, if I go and connect that up to the analysis node here and look at, let's see how accurate that actually is just based on the data that we've got. There are 1,600 records. It's about 67% accurate. It's not bad. It's a lot better than 33%, which is what it would be if it was just average. And you can see it's picking up 323 of the detractors accurately. It's struggling a little bit with the passives, as we've seen before. It's doing a pretty good job of predicting promoters, where 640 of the promoters have been predicted as promoters. So that's kind of interesting. What would be perhaps more interesting is what happens if we start to combine this data with the operational data. Can we boost the accuracy with which we predict these outcomes? And that's what we'll look at next. So in this final example, we're going to use or allow the model to use additional fields from within the operational and transactional data to help predict the outcome, whether or not people are promoters or detractors or passives, combined with the new data that we created from mining the text. So if I just connect up my model again, if I look inside the Levitt node here, you can see that I'm not just using the text data here as indicated by txt, but I'm also using things like the number of nights, whether or not they're a returning guest, their booking category, the surcharge, a discount, etc., etc. And if we run that, it'll produce a model for us. And when we look inside that model, first thing it tells us is, what are the most important fields that it's using. It turns out spend is still the most important field, how much money they're actually spending. And then we've got discount the surcharge, which is also important, but now we're starting to pull in information that we've mined out of the text. So whether or not there was something related to noise or lack of cleanliness, or if they mentioned excellence or disappointed or upset or negative appearance. And if we look at the model, we can see that again what it's trying to do is it's trying to partition, the people who are really different from one another in terms of their responses. So if they mention unclean, for example, lack of cleanliness, then 86% of them are detractors. There's still only 72 records in there. If we look alongside here, we've still got 1,600 records left, but 48% of them are promoters. If they don't mention the fact that they're disappointed or upset, then that jumps to 50%. If it's not wedding related, that jumps to 52%. If they don't use the term average, it jumps to 53%, and so on and so on. So we start to go into it, and then we start to find thresholds and spend here, and it's a much more complex set of rules that the decision tree is pulling out. Okay? And what we would expect from that, because we're using more data, is we would expect it to produce a more accurate result. So let's find out if it does that. In the previous example, we were producing results of about 67% accurate. Now we're using both operational data and text data, and if I put an analysis node on there and ask it for a little crosstab to show me how accurate it is, it's coming out at 81% accurate. So that's a significant improvement. We can see that 360 detractors have been correctly predicted, 254 passives have been correctly predicted, and 744 promoters have been correctly predicted. That's a pretty good result, and we'd regard that as a pretty good model. So what we're finding here is that by using a combination of the text data and a combination of the operational data, we're actually able to predict people's responses. Now, in reality, if we were trying to apply our model to people who we haven't asked to provide us with a score, or people who refuse to provide us with a score, we can't use the text data. But what this does is it allows us to really see the interaction between the operational information and the text data, and to find out, whether or not we can actually accurately predict an outcome, and how much of a difference the text actually brings to our ability to predict accurately. So what can we conclude from this process and this journey that we've been on? Well, looking at the last example there, although the text analysis shows some improvement in the model accuracy, the real benefit, of course, is going to come from enriching the insight that the overall analysis brings. Previously, the models predicting people's recommendation scores were dominated by fields related to things like discounting and spend. But with the addition of indicator fields from the text analysis, the key driver is now going to include things like noise-related problems, or disappointment, or issues of perceived cleanliness, or negative appearance. Generally speaking, our conclusions are, of course, that it's possible to predict NPS scores, i.e. people's recommendation scores, of the overall customer base, even if the majority have not been surveyed. And it may even be possible to do this before they've checked out of the hotel, so while they're still receiving the service. The NPS prediction allows the hotel chain to identify high-value guests who fall into the persuadable group, i.e. the passives, with carefully targeted offers, and these guests may be converted to promoters. The initial models show a clear issue with higher spending guests being more likely to be detractors. However, even modest discounts up to 10% are very powerful drivers of positive promotion. And the text analysis has revealed a list of critical issues which can convert passives and even promoters into detractors, and vice versa. But these are often very practical issues, and they can be prioritized to drive the overall NPS score upwards. I do hope you found that useful. If you'd like to find out more about Smart Vision's predictive promoter solution, then please visit our website at sveurope.com. Thanks for watching.